Similarly, you have to draw for cold stream. Here there is an example for that. Have a look. There is a one hot stream and second hot stream is there. So one hot stream is 125 to 50 degrees Celsius. There is a hot one curve is 125 to 50 degrees Celsius. CP value is given. Delta H is 150. They already calculate MCP delta T. So 150 kilowatt is there. So you must maintain the 150 here. Have a look at the x-axis 150 kilowatt and at the delta T 125 to 50. Here it is. There is a yellow line is indicated as a hot stream curve. Okay, now similarly for hot stream 2, so 90 to 40, you have to maintain the 300 kilowatt. So there is a x-axis is there, so you must maintain the 300 kilowatt by use of x-axis scale, and you must maintain the delta T value at the y-axis similarly. Okay, now how you merge these two curves? Again, there are few guidelines how you merge it. How you merge it? Here there is a few common term between two lines. There are few common terms, or you may use the diagonal rule. You may use the diagonal rule, or you may use the common term between the two lines. Common term between the two lines. So here they shifted the hot stream 1 curve to touch the hot stream 2. They shifted over here, and then in the next part they add CP1 plus CP2, that is delta H1 plus delta H2 for the both stream curve, and you will get the total delta H, that is the complete diagonal. So here it is, slope is 1 upon 2 plus 6. 2 plus 6 is nothing but the CP value. Doesn't matter, you can use diagonal rule as well, or you can spot out the common section between the two streams curve and leave it the common stream and make it as a 1. That is the delta delta H. So add delta H1 plus delta H2, you will get total delta H, and you can measure that total delta H in the x-axis. It's getting 320. Total delta H, you will get it, it's completely 320. So you can plot here, that is one complete section. So what about the topmost section, that is 125 to 40 degrees Celsius? Here it is slope of 1 by 2. What about that? So you can move it towards the left side. You can move it towards the left side. Have a look. They move this section to the left side. Okay, and they merge it. So this is the complete curve between the hot stream 1 and hot stream 2. Okay, this called as a hot composite curve. This called as a hot composite curve. Either you can use diagonal rule or addition of delta H1 plus delta H2. This is the simple graphical technique. I will tell you in the next session. There is another method for graphical technique that I already discussed in the class for regular batch. That is another simple technique. If you feel this one is too difficult, so I can tell it to you in the next section. And this is hot composite curve, and there is a slope section according to their stream. So here it is, slope is the 1 by 6 for hot stream 1. Here it is a combination of both stream, so that's why the CP value is 6 plus 2 and 8. Slope is 1 by 8, and here delta H is, total delta H is 320. Again at the last section there is a CP for only 2. Okay, cause there is a hot stream CP is only 2 is there, so nothing the part of hot stream 1, so that's why the slope is 1 by 2. Okay, then again what happened in the many problems, the two curves did not find, you cannot find the common term, you cannot find the common term between the two streams. Okay, so how you merge it, here it is. Have a look, there is a first curve and there is a second curve, but there is no common term between the two lines. Here it is, there is a two common terms. Have a look, there are two common terms, here it is, but this line is completely touched to the hot stream. Here hot stream 1 and hot stream 2 touch with each other, but what happened in the next problem, they did not touch with each other, okay, according to their temperature profile. So there is a conditions for that. The figure shows that the hot stream is moved and brought, the value of delta H is 150 kilowatt, hot stream 1 and then hot stream 1 and 2. Here you did not calculate this delta H or delta T value here. So here the touching point is, you must take one vertical line between the two lines, but the did not add the delta H value. So here is the statement is there, enthalpy change for vertical line is delta H is equals to 0. It does not count or it does not alter the load the system. However, it joined 130 degrees Celsius levels to 125 temperature level. You must join this by use of vertical line, but you must keep in mind that delta H value should be 0 for the that small section of that vertical line. Don't count it delta H value. If you counted, your calculation may be wrong. Okay. So suppose there are three streams are there, three hot streams are there. Suppose there are three hot stream. So similarly, so these three lines did not touch with each other. So you may keep with the vertical lines. Have a look. There is a vertical lines are there, but delta H value should be 0. Okay. So three streams data is there. Doesn't matter in industry. There are too much streams data is there. According to your educational point of view, there are two hot stream, two cold stream, one hot stream, or four hot stream, four cold stream, three hot stream, three cold stream, three hot stream, one cold stream. The possible, but in industry there are around 10 to 12 hot streams and there are multiple cold streams are there. So what happen when you try to solve with the help of graphical or algebraic? So there is a hectic, there is a time consuming method. So there are softwares are available in the market, you can use it and solve it. In Aspen energy analyzer you can do it as well. There is a small section is available, Aspen energy analyzer. You can use that module or interface and solve the pinch analysis. Okay. uh, Again, there is another similar problem. There are two streams are there, these streams are touch with each other. Yes, it's possible. Yes, they attach similarly here because they move the curve of second curve to the right side and touch with each other. Okay, and at the top section, so move it towards the left side. Once you add cp1 plus cp2, you will get the total delta H. Cp1 plus cp2 into delta T. Cp1 plus cp2 into delta T. You will get total delta H and use complete diagonal section and move the topmost section towards the left side and join it. You will get the hot composite curve like here. Okay. Similarly, you must try for cold stream. You must try for cold stream. you will get cold composite curve. So these both composite curve, that is hot and cold stream cold composite curve, you must draw in one another graph, that is called as the TH composite curve data. And then you will get the pinch temperature, how much utility required, how much cold utility required. Few problems, again there are few examples or few problems are there. There is a CP1, CP2 and CP3. There are three lines are parallelly in the same section. So how you add or how you merge three lines? By use of CP1 plus CP2 plus CP3. Calculate CP1 plus CP2 plus CP3 into delta T. Delta T is nothing but T2 minus T1. You will get total delta H. So total delta is nothing but complete diagonal section, that is point from this to the last.